All right, so this video is going to finish up section 3-2, and we are first going to look at two examples where we are given the vertex and a point on a parabola, and we need to write the equation of that parabola. Now, what's going to be most helpful for us is if we use vertex form of the parabola. So just as a reminder, that's y equals a times x minus h squared plus k. And what we're going to do is we're going to plug in that vertex and we're going to plug in this point. So I'm going to leave the y value blank right now. I'm going to leave the a value. I don't know what is stretching or maybe reflecting my vertex. And then I have x minus, and my h value is -2, so that will actually be +2 here, squared. And then plus k, but my k is -1, so -1. Now, instead of x here, I'm actually going to plug in my x and my y value in this point. So this is my x and this is my y. This was my h and this was my k. And I'm going to plug in that x and y. So my x is -4 and my y is 3. And now there's only one unknown in this whole equation, and that's a. And so this is going to allow me to solve for a. So -4 plus 2 is -2. -2 squared is 4. And so I have 3 equals a times 4 minus 1. I can add 1 to both sides. And I have 4 is equal to 4a, so a equals 1. Now, my a value is 1, and I know my vertex, so I can write this equation in vertex form. And so that would be, let me write it over here. Vertex form is going to be y equals, my a value is 1, so I don't really need to put a 1 out front there. You can if you'd like to. And then I have x plus 2 squared minus 1. So that's vertex form. And then I also need to write it in standard form. So I'll just set that up right there. And what I'm actually going to do here now is I'm going to use this vertex form, y equals, and then my a value is 1, x plus 2 squared minus 1. And I'm going to use the box method to multiply that out. I'm not going to show my work for that box method. If you want to use FOIL or the box method to multiply that out, you can. And what you would end up with is x squared plus 4x plus 4, and then that minus 1. And then combining like terms, we have x squared plus 4x plus 3. And that would be the standard form of that parabola. Okay. Let's do another example. Just as a reminder to myself, I'm going to write vertex and standard. So I have my two answers over here. And I'm going to do the same thing. So I'm plugging in my vertex and the x and y values. So this is my h, this is my k, this is my x, this is my y. So -8 for y. I don't know my a value. My x is -1. My h is -3. So that's going to be plus 3 squared and then minus, okay, minus 4. All right. We can go ahead and simplify some of that. I have -1 plus 3, that's 2. 2 squared is 4. So -8 equals a times 4 minus 4. I can add 4 to both sides. And I get -4 is equal to a times 4. And dividing both sides by 4, a is equal to -1. So writing this into vertex form, I have y is equal to -1 times x, and then this will be plus 3 squared minus 4. Well, I can go ahead and use that now to rewrite this into standard form. So I have y is equal to -x plus 3 squared minus 4. And then foiling this out or using the box method, I'll end up with x squared plus 6x plus 9. And distributing that negative, I have negative x squared minus 6x minus 9 minus 4. So I have y is equal to negative x squared minus 6x minus 13. And that's the standard form of that parabola. All right. So the next two examples are a couple of word problems. And the first word problem says you have a rectangular field that you want to divide in half and surround with 300 feet of fence. So we have a rectangular field that we need to surround with 300 feet of fence. We also want to divide it in half. And then it says, what dimensions allow you to maximize the area, and what is that area? So I have 300 feet of fence total. And we know with rectangles, opposite sides are equal, which means this side is also equal to these sides. I'm going to call all three of those x since they're all the same length. And if x was, let's say, 10 feet, well, then I would have used 10, 20, 30 feet. So I would have 300 minus 30 left. If this was 20, then I would have used 20, 40, 60 feet, and I'd subtract that, and I'd have 340 feet left. I don't know what this length is. So I have 300 minus 1, 2, 3x. So 300 minus 3x is what's left, but I need to divide that among these two sides. So I need to divide that in 2 for these two sides. So divided by 2. And you could write that as 150 minus 3 over 2x. So that gives me a length and a width of my rectangle. And if we want to maximize the area, I need to write a function for the area. And that would be the length times the width. So x times 150 minus 3 over 2x. So I can distribute that x now, and I have a of x is equal to negative 3 over 2x squared plus 150x. And I want to find the maximum of that parabola. Well, knowing that this parabola is going down because it's negative, that vertex will give me my maximum. So I'm going to try and find that vertex. So negative b over 2a will give me the x value of that vertex. So negative 150 over 2 times negative 3 over 2. Here my 2's will cancel. A negative divided by a negative is a positive, and 150 divided by 3 is 50. So that's my x value. What that means is that that's the x value that would give us the maximum area. So I can use that to find my dimensions. That means this is 50 by, and then if I plug that into either one of these, I'm going to go ahead and plug it into this one. 3 times 50 would be 150. 300 minus 150 is 150. 150 divided by 2 is 75. So my dimensions are 50 feet by 75 feet. And if I want to find the maximum area, which it does also ask for, I can either multiply 50 times 175 or times 75, or I could plug it into the equation to find that maximum area. Either one is just fine. If I do 50 times 75, let's see, what do we get? 50 times 75, and we get 3750. So 3750 feet squared. And that answers that question. Now that last one says a ball is thrown upwards from the top of a 40-foot building at a speed of 80 feet per second. The ball's height above the ground can be modeled by the equation given here. And it's nice that they gave us an equation here. And so it says, when does the ball reach that maximum height? So what we want to do then is find the vertex of that parabola. So I can go ahead and plug in negative b over 2a, negative 80 over 2 times negative 16. And 80, well, we have a negative divided by a negative, and so we know our answer is going to be positive, which makes sense because we're not going back in time. We're solving for when, so we're solving for time. And I have 80 divided by 32, or yeah, by 32. That gives us 2.5. So what that tells us is that at 2.5 seconds after the ball was thrown, that's when the ball reaches its maximum height. Part B is asking us, what is the maximum height of the ball? So I can find h of 2.5, and I can find out what that height is at 2.5 seconds. So 16 times 2.5 squared is 100. And then 80 times 2.5 is 200. And this is actually a negative 100. That looks like 700. Let me fix that. And then plus 40. So 140 feet is that maximum height. Okay. And then the last question is, when does the ball hit the ground? Well, the height when the ball hits the ground would be 0. So what we're looking for with C is, when does the height equal 0? Okay. Now we want to solve this and then setting it equal to 0. I notice that all of these numbers are divisible by 8. So I'm going to go ahead and divide by -8 on both sides of my equation here, just to give me smaller numbers to work with. -16 divided by -8 is going to give me 2t squared. 80 divided by 8 is going to give me -10, because we're dividing by a negative here, and t. And then 40 divided by -8 is going to be -5. Now I could try the box method, but it's not going to work, so I'm going to go ahead and use the quadratic formula. So we're plugging in -10 minus 4 times 2 times -5 all over 2 times 2. And we end up with 10 plus or minus the square root of a negative times a negative is going to be a positive. 4 times 2 is 8, times 5 is 40. So 100 plus 40 is 140 over 4. 140 is divisible by 4. And so this is 4 times 35. So I can rewrite that as 2 root 35. And I can reduce this. So I have 10 over 4 plus or minus 2 square root 35 over 4. Both of those can reduce. And so I have 5 over 2 plus or minus square root 35 over 2. Now, 35 over 2 is bigger than 2.5. So if I'm going to subtract that from this one, I'm going to get a negative answer. And so this -1 here is not actually going to give us a solution, because we can't go back in time. So what I'm interested in is 5 over 2 plus square root of 35 over 2. So let's go ahead and find that. And then we will see at what time it hits the ground. So we get 5.45 seconds. So the ball is in the air for 5.45 seconds, and at 5.45 seconds, it hits the ground. And that will bring us to the end of section 2.